Here's problem number 23 from section 8.1. We're given this sequence, and we could calculate the terms in this sequence. When n is 1, we get 1 over 1 squared plus 1, we get 1/2. The second term in the sequence can be 2 divided by 2 squared plus 1, that's going to be 2/5. The third one is going to be 3 divided by 10. Then 4 divided by 17, then 5 divided by 26, and then so on and so forth. 6 divided by 37, ... infinite, goes on infinitely. So what does this sequence look like when it's graphed? Well, we're going to treat the horizontal axis as our n-axis, and let's call this spot right here 1. So 1 comma 1/2, 1 comma 1/2, 2 comma 2/5. These are in each one of these is a fifth, so 2/5 would be here. 3/10 would be about there. 4/17. 4/17 is a little bit less than a quarter. 5/26, so on and so forth. So what we see is this steadily declining value. In fact, if you ask yourself another question, what's the limit as n approaches infinity of this n over n squared plus 1? Using our intuition, we can see that as n gets really large, this plus 1 doesn't matter much, and you end up with n over n squared. So it is essentially 1 over n, and we know that 1 over n is, as n goes to infinity, is 0. And what we're going to have is a sequence that gets closer and closer to 0 as time goes on.